Thank you for watching Knowledge Academy.
All right, let's start it. So think about it. I'm going to say one thing. Get, the cross product basically we are talking about. If I have a vector here, which is a different color, maybe green vector, right? I'm going to take this one. Okay. So if I have two vectors, let me just do it. If I have a vector, green color vector, A, and then I have yellow color vector, which is B. Okay. Now the thing is that if I multiply the two vectors, I have two options. Number one, I want just a magnitude. I just want a magnitude of the two vectors and I use it, call it dot product. But if I want the magnitude and direction, I want a magnitude plus direction, right? I have to focus on, I have to go to the cross product. Now, cross product, first of all, we need to talk about the physics behind the cross product. Cross product is only used to turn things, right? To turn, rotate stuff. That's what it means. So what you guys think, A and B, does A and B, some of you, please put yourself on a mute if you're not talking. There's a background noise coming. I'm not sure who is that. But do you guys just answer me a simple question? Between vector A and B, do you think B able to rotate A or A able to rotate B? Yes or no? Or they are in the same direction or they are in the opposite direction? What you guys think? Does A and B able to rotate same direction? So they could not able to rotate. They could not able to rotate. So cross product is basically measuring how perpendicular two vectors are. How perpendicular. How perpendicular two vectors are. In this case, none. Right. So what I'm going to do, I'm going to take vector B and I'm going to make vector B like that. Okay. In this case, A and B are trying to rotate each other. And basically what's happened, this whole thing is going to be rotating. Or vector A is going to be rotate. And they combine produce a turning effect. So what's happened? A is here, B is here, and they're able to rotate things. So what I'm going to say is, are their cross product? What is the cross product between A and B? A and B. So in this case, the first one you're going to say A cross B equals to 0 because this is A. I'm going to write it. A cross B equals to 0 in this case, right? I'm going to erase this guy and I'm going to move to the next case and I'm going to say here A cross B is maximum because they are maximum rotate each other. So the third case scenario I have, this one, the other one, I'm going to call maybe 1, 2, and I'm going to write here third one. So I'm going to say is 1 equals to 0. Number 2 case is maximum. Number third case, which is my goal today, is talk about this. So I have a vector A here, you know, I have a vector A, and I'm going to be just drawing those things for X. In third case, I have a vector A, and vector B is not really straight, is not really parallel, is not even perpendicular. Vector B is in a little bit weird situation. Vector B is in angle. So what I'm going to do, if I have a vector B in angle, I'm going to split this vector. I'm going to split this vector. And after I split this vector, I'm going to be putting this dotted line here, or dotted line here. And I'm going to use called Bx and By. Now pay attention here. This guy and this guy combined does not produce anything. It's going to be zero because they are parallel to each other. Okay. Now this A and this BY not parallel to each other, they produce something. And that's exactly the max part. But unfortunately, BY is not BY. BY has some other values. So I'm going to be writing here, right? A cross B in third case equals to A magnitude, B magnitude, but B is not combined complete. I cannot use the B. I have to use B. I have to use this guy basically. B cos theta. What is cos theta? Theta is this angle. Okay. And I can write this formula in another way. Cos theta, I can write down in this way. Okay. So that is done. Now, the thing is that, remember I told you, I need to find the magnitude and direction. So this part is only magnitude. This part is magnitude. I need the direction here. And this direction I put n vector. And I'm going to write here something about n. N is perpendicular. Perpendicular, this is a perpendicular sign. Or I say is 90 degree to both A and okay, both A and B. So let's go to the next slide and talk about more stuff about cross product. Does anybody have any question about this, what we learned so far? Turning effect, two vectors are perpendicular to each other, they turn a lot, they turn maximum. If two vectors perpendicular, partly, like number third case, partly, only by is perpendicular, not bx. They only produce some effect. So put it this way, number three is in between number one and two. Number one is almost zero, right? Number two is maximum. Number three is in between the two. Number three is in between number one and two. So let's talk about some theory and then quickly do some problems. Okay. So I'm going to write some notes about what is a cross product formally. Number one, cross product of two vectors is a vector quantity. Yeah. Number two, vector product also called cross product equal to what? A cross B equal to the magnitude of A, the magnitude of B, and then cosine theta. And n is the unit vector of the direction, and theta is the angle between the two. Okay. So let me draw here a little bit. So since I have, I'm going to draw here like that, like an angle. So this is a y, this is x, that is z. Let me just draw something real quick. So vector A is going to be in this direction. Vector B is supposed to be, if it's in this direction, they are perpendicular. If it's in this direction, they are parallel to A, but they are not. I'm going to draw vector B with certain implication. I'm going to write vector A is this. Then I'm going to take another color, yellow, and call B is an angle. But B is an angle between the two, like on the back plane. I'm going to say is that B is located on YZ plane, like this plane, the back. Since vector B is not along or parallel or perpendicular to vector A, I have to split vector B into two portion or two component. Number one is this, number two is this. I'm going to call this Bx, and I'm going to call the other one By. Here, Bx equals to B cos theta, and By equals to B sine theta. Yeah, my bad. If I take the angle with y-axis, I'm going to just write here. It should be sine theta because we are taking the angle with x-axis. Okay. So I'm going to put this one, and this one is also sine theta. I'm going to go here. I'm going to change this. Remember, when we're changing the angles with x-axis and y-axis, these theta could be changed. Right? If I take the angle with here, this is what I wrote. But if I take the angle on the other side, like z-axis, it will be sine becomes cos, cos becomes sine, right? But this is pretty much like a standard formula. Let's talk about a couple of more things before we do the problems. Number three, it does not obey cumulative law. It does not obey cumulative law. It doesn't. It means A cross B not equals to B cross A. If you remember dot product, they obey commutative law. This one not. Now talk about what is N. Let me change the color of N, maybe this pink color. N. N is perpendicular to both A and B, or both component of A and By. So you see this component is completely gone because they are parallel to A. Only this component move here, right? This component. Now talk about N. What is the N? N goes by right hand rule. So you take your right hand rule, and what you do, you just basically using your right hand rule, right? And what you do, you just try to rotate or curl your finger from first vector to the second vector, from first vector to the second vector, and this thumb, showing the direction of it. So in this case, if I rotate my hand is going to be pretty much look like, you know, A to B is going to be, I want to say it's going to come like this. If I move my finger from here to there, rotate from A to B, why? My thumb actually telling me the N supposed to be here. I'm going to change the color. My N actually this direction, inside, like a z-axis, inside the plane. And if I rotate other way around, it's going to be towards this side, right? So basically N is perpendicular to this. So if I'm going to draw two vectors, if my vector A is this, and my vector B is this, you can imagine the thumb actually towards you, right? If you take your right hand, curl your finger from A to B, the thumb is going to show towards you. But if you make this making A and this one making B, and then now you turn your right hand, your thumb is going to go inboard to the screen. So that's why you're saying A is not equals to B, A cross B not equals to B cross A. That's what it is. Okay. Number 4, cross product of parallel vector like, A cross B, A cross B equal to 0. We already talked about that. If two vectors are parallel, their product should be 0. And cross product measure how perpendicular two vectors. Okay, or how much 90-degree common 90-degree angle common between the two. If they are closer to 90-degree, they are much cross product. If they are not closer to 90-degree, pretty much 0-degree means they have nothing in common. Does anybody have any question about cross product before I do some problems?
Will you talk more about like when we have to use sine or cosine in the cross product equation?
So cross product, this is a standard formula. And if you are measuring, so let me just put it this way. If you have an angle like B and this is theta, right? So that this component is B cos theta, and this component is B sine theta. So this is what I use now. But let's suppose I have another situation where I have vector B is this, but angle is given from this axis. So you have to make sure which angle you are given in the problem, or you are able to convert the angles according to the formula. So if you want to use this formula, the one I wrote like this one, you always have to make sure angle is given from x-axis or horizontal axis. So let's suppose in this case, the second one I'm just writing right now, angle is be given from y-axis. So here's what's going to happen. Here, this component is b cos theta, and this component is b sine theta. So this formula, basically, which one you're going to be using in this case? You're going to be remove this guy and start using this one. Or you know, if you already know this angle, if you already know this angle, you take this angle and minus with 90, and you're gonna get this angle. And then you can apply this again as is. Okay,
Thank you.
no problem. Let's move on to the very important thing where confusion is started. So I'm going to split that piece. If theta is given or asked, right? Is given or asked. If theta is not given or asked. If theta is given or asked, you're going to be using this. You decided which method you're going to be using. If theta, if theta is not given or asked, you're going to be using determinant method. You're going to be use determinant. Okay. So let's talk about easy method first, and then we talk about determinant method. We're going to be talking about more determinant method than the other method. So I would say number one, number two, number one, number two. Okay. I'm just trying to find good problem. Okay. So I'm going to start number one and choose one problem for number one. See the problem. Okay. If u equals to 3i plus 7j plus k and v equals to 2i plus 2j plus k, find a u cross v here in this case, find u cross v, and we need to find out the angle. Okay. And we're going to say that find u cross v and angle between u and. Now here is the issue is that in this case, I'm going to go back and talk about which method should I use. Which method should I use? In this case, I'm trying to cover two things in one. In this case, I need to find out this. Let me just go back here. So they are asking, you need to find out this theta. Here, u is given, v is given. You can find out these two in magnitude. But u cross v is not given in this problem. So I need to go and then find out this u cross v from second method, right? And then finding u cross v from this method. And then after I found this u cross v, I'm going to go back and then find theta. Okay, so let's do this problem with u cross v method, and we're learning u cross v. Then after we come back, after we find out u cross v, we have some values here. We're going to be use this value substitute here, and then we find out this guy, and then find out theta. Okay, let's go to the next slide again. So u cross v is, I'm going to write a determinant. If you don't know what's a determinant, it's basically a matrix. I'm going to write a matrix. And I'm going to write these two vectors in a matrix form. And how can I write this u and v in a matrix form? I'm going to say is u and v have three components, I, j, k. You have I component 3, 7, 1. V, this is basically u, and I'm going to go to v. We have three components, 2, 2, 1. I'm trying to do what? I'm trying to multiply the 2 by using this method. So really my goal is u cross v. And I'm going to start with that. In order to starting with that, when I'm going to take one by one, so the method work is like this. You're going to take this I, so you're going to ignore this column and this row and multiply this 7 to 1 minus 2 times. This exactly is going to be 7 times 1 minus 2 times 1 when you do the I. Okay. When you do the j component, you're going to be taking j component, ignore their column and ignore their row, and multiply this 3 with this 1 minus this 2, this 1. When I do the k component, I'm going to take this k component and I'm going to be multiplying these, ignoring these two column and rows, and then multiply 3 to 2 minus 2 to 7. Take a look how it's going to be looked like. Okay. So basically, I'm going to be doing the I first. So I'm going to be writing I. So I'm going to take 7 times 1, right? 7 dot 1, not 7.1, it's 7.1. I'm multiplying minus 2 dot. Okay. Then I'm going to be, it's going to work like this, plus, minus, plus. So second quantity, I'm going to be using the answer from the formula. This minus came from formula. Okay, that's how I'm going to be writing plus, minus, plus, minus. This is how you solve the determinant, plus, minus, plus, minus. So I'm going to do first one is plus, second one minus, third one will be plus. And I'm going to write in the second component. When I do the second component, I'm going to be doing j. Okay. So when I do the second component, it will be j what I'm going to do, I'm going to be taking this j, ignore these two, multiply this to 1, 2 to 1. But there is a minus sign in between the two, just like here. Okay, so let's do it. First one we're going to do slow. Next one will be getting up a little bit faster as we understand this method. So it's going to be 3 dot 1 minus 2 dot 1. The third one will be k, should be plus. Okay. So I'm going to say 3 times 2 minus 2 times 7. So 3 times 2 minus 2 times 7. Let's solve this. It's 20 is 7 minus 2 I 3 minus 2 j plus 6 minus 14. If I further elaborate this one, is going to be 5i minus j, right? 2 minus 1 is 1, minus 1j plus, with minus sign inside, there is a minus inside. So maybe I'm going to write minus 8k, right? And I can just write this thing again, 5i minus j plus 8. And really this is my pretty much my answer for u cross v. And this is my u cross v. Am I done with the problem? Not really. I need to find out u magnitude and then v magnitude. So u magnitude is going to be 9. So 3 squared, just write step by step. 3 squared plus 49 plus 1. And this is going to be 4 plus 4 plus 1. So this one is, what is the values you're going to be solving it? It's going to be 9 plus 49, right? 9 plus 49, 40, 58, and 59, right? This one will be 4 plus 4, 9, and also right. Okay, now using the cross product formula, I'm going to see u cross v equals to. Now I need the answer from that, so I have to use the magnitude. Oh yeah, this minus 8. So I need a u cross v. Let me just write the formula without this magnitude. The formula we learned, u v sine theta n. For now, just ignore the n. N will be perpendicular to both u and v. Okay, so I'm going to ignore the n for now and leave the n for now. Now here I found out u and v. So u is here, v is here. I need to find out the magnitude of the two so I can solve it. So what I'm going to do, I'm going to be just writing here. I'm going to say u cross v magnitude E divided by u magnitude times v magnitude equals to sine. From here, what is the u cross v magnitude? Is going to be 25 plus 1 plus 60. What is an answer when you solve this? Square root 90, so 64 plus 26 will be square root 90 divided by square root 59 times square root, so just when you solve this whole thing and give me what is the value of sine theta. Sine theta equals to square root of 9 divided by square root of 59 times 3. Zero 0.412. Is that the correct answer? Everybody else got this? Okay. Now here, what I'm going to do, I'm going to take this value and then take the sine inverse. So theta equals to sine inverse 0.412. Tell me theta, what is an answer? Sine inverse, put in a calculator, and then depends on what calculator you have. Sometimes you have to enter the value first and then sine inverse. Some calculator you have to say sine inverse and then put the value. One student says, Luke says 24.3 degrees. Anybody confirm? Okay, so it's about 24.31 degrees. Right? We're going to do one more problem.
Why did we take the magnitude of u cross v?
Why we did that? Because we need the theta, right? If I don't take the magnitude of u cross v, how can I divide the whole? Remember, I need the magnitude in order to find the division. If I don't take the magnitude, how? That's the whole purpose of finding the u cross v magnitude, to find this. Yeah, u cross.
Okay.
Yeah, u cross v not net. U cross v does not change. Let's put it this way. It's very clear, guys. U cross v is a vector. That's what we learned. U cross v is a vector. Which vector? U cross v is this vector. But since I need the theta, I have to find the magnitude of u cross v. So I can substitute here and then take the u magnitude and v magnitude, substituting here. And then what's happened? Once I find the theta, I can give the theta values. Now the question is that nobody asking about this n, but we already learned n is perpendicular to u and v. So if I'm going to draw u, let's suppose I'm going to draw u like this and v like this. Right? This is u, this is v. So where the n would be? N would be this. And if u is here, v is here, right? This is u, this is v. Where's the n? N would be here, perpendicular to this, perpendicular to this. Again, n perpendicular to u and perpendicular to. So this is n. We don't want to be writing n because we know this vector is 90 degree to both u and. Already?
Let's take a look at another problem.
Find the unit vector that is orthogonal to both u and v. I'm going to say u and v. So what I'm going to do in this problem, by looking this problem, I need to find out u cross v, and there will be a vector with I, j, k. And this vector actually orthogonal means this vector is 90° to both u and v. That is what is asking the question. And then what I'm going to do, I'm going to take this vector and make a unit vector. I'm going to take this vector and make a unit vector. So let's do this problem real quick and then go from there. This is just a theory. So what I'm going to do, I'm going to solution. My u is given something like this. Now u cross v, need to find out the determinant I, j, k, and then I'm going to write in the vectors 4 minus 3, 1 is going to be 2, 5. Since we already learned something, so we're going to do a little bit faster. This time I'm going to write these multiply these two. So minus 9 minus 5 will be minus 14. Minus 3 times 3 minus 9, 5 times 1 is 5 minus 5. So minus 9 minus 5 will be minus 14i. Then minus with the formula minus, one formula here, minus sign. And 4 times 12, 3 is 12, minus 2 times 1 is 2. So 12 minus 2 will be 10, 10 with minus sign. Plus 4 times 5 is 20, and then minus 2 times 3. So there will be plus. So 20 plus 6 will be 26. So we need to find out the unit vector. So what we're going to do, we take the unit vector. How do we find the unit vector? Unit vector of u cross v. That's it. That is my u cross v. The unit vector of u cross v is equal to what? I'm going to take u cross v and divide it by its magnitude, its own magnitude. That's what we're learning earlier, right? If I take the unit vector divided by its own magnitude, it's a unit vector. So I'm going to be writing this vector again, minus 14 I minus 10 j plus 26 k divided by. Now I'm going to be just writing a square root of 14 square plus 10 square plus 26 square. Minus minus, this minus is becomes plus, this minus 10 becomes plus. Okay, so I'm not writing that. If I solve this one, it's going to be look like this. Minus 14, 972. Minus 10, 972. And 26, 970. Since I'm using these parentheses, I should not have to writing ijk. I can write ijk, but since I'm using them, I have to use these commas. So the homework problem is going to be this. If u is this, v is this, find the unit vector
Let's take a look another problem.
So first thing first, we need to talk about a last thing in a cross product, and that's what you call triple scalar product. Triple. And what exactly triple scalar product? It doesn't very fancy. It just sounds like fancy, but they are not. What they do, you just take A cross B and you multiply. So when you take A cross B, the answer is vector, right? This is a cross product is a vector. When you take this vector and multiply with a scalar or a vector, but don't multiply, you just want a product. Which product? You want a dot product, and then another vector. So vector cross vector is a vector. Vector dot vector is a scalar. Okay, let's take a look at this example. It explains everything. And what exactly you write like this: A cross B parenthesis dot, make sure it's very clear dot, and then C equals to some quantity. That quantity should be a scalar quantity. Okay, it means you only need a number, no magnitude, only magnitude, no direction, right? Example, find the volume of the perpendicular, uh, the paralleloid, right? We need the paralleloid or parallel pipe is basically a pipe which is rectangular, not circular. Usually pipe are rectangular or square, you know, shapes, a circular shape, but the parallel pipe means it's a pipe, but it's not circular, right? As shown, having, here's a fun part. I'm going to be doing these things through a vector form. So it's going to be u 3I minus 5j plus k. Then another vector I have v 2I. I'm going to say just j, no I, 2k. And w, so really the three sides I mentioned in the form of vectors. Okay. So what I'm going to do, I need to define like this. My volume equal to u dot product v times w. Yeah, maybe I can put the magnitude here if I want to. Really, I don't have to. But think about it. I'm going to be doing this. I have two options. I can do dot product of this one, which is I, J, K, and I can do, here is a 3, sorry, this is V, so it's going to be 2 V's here, and then 0, 2, minus 2, and this one, 3, 1, K. Then I solve this one. Then I go and then take the dot product with U. Or I can use a shortcut. I can use a shortcut or alternative. And that's what exactly we want to learn in this topic. And what I can do this, and I'm going to write like this. So since we're starting with U, so it's going to be U1, U2, U3, V1, V2. I have to keep entering student in the class. And then W is W1, W2, W3. All I have to do is just enter all these constant from the vectors and then solve. Okay. If I want to do this, it's going to be look like this. 3 minus 5, 1. 0, 2, minus 2. These are all the constant I'm just picking up from here. Now, W is going to be 3, 1, 1. Okay. If you remember when we solve dot product, we just using multiply variable by variable. When we solving cross product, we just multiply, taking the constant from here, from determinant method and use it. Since this is look like a determinant method, so what I'm going to do, I'm going to say is I, then minus, pretty much like this, right? This is what we learned, j plus k. But what I'm going to do now, I, j, k replaced by 3 minus 5, 1. Okay, so this one is replaced by, this one is replaced by, this one replaced. So this is exactly what I'm going to do. I'm going to replace them in my determinant method and writing here, this one is 3, right? Minus minus 5. So I'm going to say minus minus 5. And this one is going to be yes. I'm going to write in the end so you guys see a bit better. Minus 5 plus, and then here is going to be 1. Okay. This is the way we just wrote, and all I can do, I just multiply. So here in 3, I can multiply 2 times 1. So it's going to be 2 minus 2, and then there's a minus. So minus minus plus to 2 plus 2, so it's going to be 4. The second parenthesis, I'm going to go and then ignore this row and this column, this row and this column. So 2 times 1 is going to be 0, and then minus 6, and then minus minus is going to be plus, so it's going to be just 6 with plus sign. The last one is going to be minus 6. Okay, I multiply these two and these two. When I solve this, you know there is no ijk, so really automatically I'm going to get my, I can just write here, so I have 3, 4 plus 5 times 6 plus 1 times minus 6. When you solve this whole thing, is going to be 36 volume. And that is pretty much my answer. Volume 36, it could be meter cube and thing. Now this is pretty much a scalar. If I want to draw this, it's going to be looks like amazing. This is how, let me just draw here. So I'm going to say is U, V, and then W, right? It's very important we just follow the discipline U, V, W, but we take the cross product for V and W, right? We take the cross product from V and W. So I'm going to be making a, right? And in this diagram, I'm going to be making two vectors. Maybe one is V, one is W. So maybe here, V is here. And then after I take the cross product, I make like a this hatching area. Like this is my V, this is my W. And then I'm going to be taking U. So my U is going to be inside the board. And what I'm going to be doing, I'm going to be just connecting them. And that's my volume. It's basically look like a, parallel pipe or a solid cubicle shape. Okay. Now let's move on to the application of cross product.
Let's take a look another problem.
In this problem, we are talking about application of cross product. So I usually say is A cross B equal to C. And this C is 90 degree to both A and then B, 90 degree to both and B. I want to do application. So what I'm going to do, I'm going to make a application and say store, which is a physical quantity equals to force times distance. We call it moment arm in physics. So let's talk about just a mathematical part of torque. We're not going to discuss torque at this point. If you don't know what is torque, torque basically physical quantity, which is a cross product of force times moment arm. What is a moment arm? This d is a perpendicular distance between force and uh, the origin, where you apply the force, and what is the turning point of rotational axis. That's perpendicular distance. So what I'm going to do, I'm going to apply this whole thing into this application. So let's jumping into that. So first thing first, I'm going to be drawing this on a side by side. So here, I want to draw something. So really I have, this is my force applying, and this is my force, and then moment arm, which is my D or R. It should be from here to here, this distance. So what I'm going to do, I'm going to take this 6-inch arm, which is this from here to there, 6-inch arm, and take the component like this component. So really you can see here, let me just take another color, maybe red color. So this red color vector and the blue color vector, they need to be have a cross product. So you can see force is coming down, this guy is coming this way, right? Which is maybe I can call Rx, and there's a Ry here. Ry is not concerned of us because Ry is parallel to F. We don't care about this. We only care about Rx. So Rx, I'm going to take the cross product for these two. Force times Rx. And I'm going to produce another quantity called torque, which is tau, the symbol torque. And this torque should be perpendicular to both F and Rx. So really it's going to be towards us, right? So basically you can say here, if this guy is trying to push this pedal, torque is going to produce and coming towards me and you, or inside the boat. So there is two options. Which one should I pick? The torque. Torque should be inside the board or out of the board. If you guys remember, we learned about a rule called right hand rule. So you take your fingers and try to curl them from one direction to another, right? And it's basically telling you the thumb's direction. So you can see here, if I'm trying to take my right hand and take from force to Rx, so it's going to be moving like this. This is my torque, and I try to curl them from force towards RA or Rx. If I curl my right hand finger from force to Rx towards Rx, try to curl them, fold them. So when I curl them, my thumb actually telling me torque. So it means torque is coming out of the board or out of the screen. Okay. So let's try to solve it. So I'm going to say is my force equals to minus 20 and towards down. So there is only one vector. There's no I, no K, there's only J. That is my force vector. Find my force vector. Because set down should be K, right? We learned about that one like this. So this is K. I usually say this one is X or I. This one is Y and J. And this is Z. So it's minus K because downward force. And the other one should be PQ. PQ is a distance, so P point is here and Q point is here. We're going to do this one. Now PQ is equals to half, because these are in inch. I want to go in feet, right? So I divide it by 2 to convert the inches into foot. and 40 degrees J plus sine 40 degrees K. Yeah, both should be positive. I just divide that down. Now I'm going to be taking the cross product. So cross product is PQ times force equal to I J K. Make sure you just always doing this. PQ times force, right? Not F times PQ. It's going to change the direction. And I'm going to substitute the values here, 0, then cos 40 degree divided by 2, then sine 40 degree divided by 2. All I did just take these two components one by one, I substitute him. The last part, which is force doesn't have any vector besides k. So I'm going to say 0, 0, 0, 0, and then minus. Okay, let's multiply this one. So when I do this, when I do I is going to be 10 times, because I multiply by half, 10 times cos 40. And the rest of them basically, you know what, when you multiply this from this to this is the only one is left over. And this guy is supposed to be 0 because it's going to be 0. Everything else is going to be 0 because you multiply this to this j is going to multiply this to this 0, this to this 0. And when you multiply, when you go to k, this to this 0, this to this 0 because these are 0. So really, I component is pretty much what we got left over. Okay, here when you solve it, you're going to get the answer 7.66. The unit should be, this one should be foot, this one should be pounds. So foot pound is pretty much like the imperial system unit of torque. Yeah.
Thank you for watching Knowledge Academy.